Moment of inertia. How we can define moment of inertia? The moment of inertia at a particular point can be defined the product of mass of the element and perpendicular distance towards the axis of rotation. Good morning, students. Today I am going to explain the important and beautiful topic in physics side, that is moment of inertia. It is fact that in translatory motion, the property of the object that opposes change in state, either rest or uniform motion along the straight line, can be known as inertia. But in rotatory motion, the property of the object that opposes change in state, either rest or uniform motion about axis of rotation, can be known as moment of inertia. So finally, the moment of inertia explains how rotatory motion changes when the mass of different points changes, and based on moment of inertia we can calculate angular momentum of the objects. Mathematically, how can you define moment of inertia? Moment of inertia can be defined the product of mass of the object and the square of the perpendicular distance. Once again, the formula of moment of inertia, I equal to mr square. M is mass of the element, r is perpendicular distance towards the axis of rotation. Now consider dm is the mass of the element. I am going to calculate moment of inertia for dm mass of the particle. dm mass of the particle which is moving with r perpendicular distance with respect to AB axis. Now, moment of inertia of dm mass of the element now, that is, let us say di equal to product of mass of the elements means dm into perpendicular distance means r square. Now I am going to calculate moment of inertia for total body, total rigid body. So I am going to integrate di equal to integration of dm into r square. It is a beautiful equation for moment of inertia with respect to particular axis. Moment of inertia, parallel axis theorem. How we can define the moment of inertia of a rigid body at a particular axis is equal to the moment of inertia about another parallel axis plus the product of mass of the body and the square of the distance between two parallel axes. As a part of moment of inertia, I am going to explain parallel axis theorem. Parallel axis theorem indicates that moment of inertia about one particular axis equal to moment of inertia another parallel particular axis plus the product of mass of the objects and square of the perpendicular distance between two axes. Let m is the mass of one particular point which is in rotatory motion. Now I am going to calculate moment of inertia towards CD axis according to formula mass into perpendicular distance. Here perpendicular distance is r minus x. Here you have to mind it, r is the distance between two axes. So x is the perpendicular distance to the AB axis, and r minus x is the perpendicular distance to the CD axis, and the two x are both are parallel to each other. Now I am going to calculate moment of inertia with respect to CD axis, m into mass into perpendicular distance, r minus x whole square. R is the distance, perpendicular distance between two axes. This is equation number 1. And second, I am going to introduce moment of inertia with respect to AB axis. M into, here perpendicular distance is x square. This is equation number 2. Now take equation of motion number 1. Equation 1. Moment of inertia CD axis equal to m into r minus x whole square. Now that equal to m into r square minus 2rx plus x square. A means b whole square. R square minus 2rx plus x square. Now inertia of moment of inertia with respect to CD axis equal to mr square minus 2mrx. So moment of inertia with respect to CD axis equal to mr square minus 2mrx plus mx square. So what equation we are getting? The moment of inertia with respect to CD axis. So it is related to only mass on particular point. Now I am going to modify the inertia, moment of inertia with respect to CD axis throughout rigid body. So moment of inertia with respect to CD axis I am going to calculate throughout rigid body. So I am going to apply sigma mr square plus sigma mx square sigma 2mrx. Inertia of moment of inertia one particular axis CD through rigid body. So sigma m is converted as m. R is the constant between. R is the constant. Why? Because R is the distance between two parallel axes. The sigma m means m x square. This indicates sum of moment of force one particular rigid body in particular plane. Of course, it is equal to 0. Once again, the sum of moment of forces at different points in a particular plane or particular rigid body is equal to 0. So I am going to apply 0. Finally, what we are getting? Moment of inertia with respect to CD axis equal to mr square plus mx square means x is the perpendicular distance to the AB axis. So that I can easily write this is moment of inertia with respect to AB axis. Hence, parallel axis theorem is proved. Now the definition of parallel axis theorem I am going to explain briefly. ICD means moment of inertia with respect to CD axis is equal to Moment of inertia with respect to AB axis plus the product of mass of the object and square of the distance between two axes. Moment of inertia, perpendicular axis theorem, how we can define the moment of inertia of a plane about axis of perpendicular is equal to sum of moment of inertia of plane about two axes which are perpendicular to each other. Iz equal to Ix plus Iy. Now, as a part of moment of inertia, I am going to explain perpendicular axis theorem. So, what is perpendicular axis theorem? We already learned parallel axis theorem. Now, I am going to explain perpendicular axis theorem. So, perpendicular axis theorem states that moment of inertia about one particular axis perpendicular to the plane is equal to sum of moments of inertia about two axes which are perpendicular to each other. So that is perpendicular axis theorem. So I am going to explain briefly. Now let m mass of the element which is perpendicular distance towards z axis. Now you can easily write moment of inertia with respect to z axis. Let us say it is having perpendicular distance r towards z axis. So we can write mr square. Now we can design. This is the distance towards y axis. This is the distance towards x axis. So this is perpendicular distance y. This is perpendicular distance x. Now, no doubt, these two axes are perpendicular to each other. So this is the right angle triangle and R is the hypotenuse. Apply Pythagoras theorem. R square equal to, from this triangle, R square equal to side square plus side square means x square plus y square. This is equation number 1. This is equation number 2. I am going to substitute second equation into first equation. So moment of inertia with respect to z axis is equal to m into, in the place of r square, I am going to substitute x square plus y square. Now, moment of inertia with respect to z axis equal to mx square plus my square. Now, moment of inertia with respect to z axis, we got mx square plus my square. So, throughout rigid body, we can apply sigma. So, all points, sum of all points. So total mass, simple I am saying total mass, sigma mx square plus sigma my square. Now moment of inertia with respect to z axis and mx square. M means mass of total rigid body plus my square. Now, the continuation, moment of inertia with respect to z-axis. About z-axis, mx square means x means perpendicular distance to y-axis, so it is moment of inertia y-axis plus y is perpendicular distance to x-axis, so it is also moment of inertia with x-axis. So finally what you can write? Moment of inertia with respect to z-axis equal to sum of moments of inertias of two axes which are perpendicular to each other. One is x-axis, other one is y-axis, equal to inertia of momentum with respect to z-axis. This is perpendicular theorem in the part of moment of inertia.